अंकित क्या कर रहा है? चल ना यार रिकॉर्ड करते हैं. कब से बोल रही हूँ तेरे को?
तब से तो तू
कहाँ
रील्स
busy?
देख रही थी.
मैं रील्स देख रही थी. तू किधर बिजी है?
चल अब स्टार्ट करते हैं ना.
चल बैठ.
पूछ क्या पूछना है. चश्मा क्यों नहीं पहना तूने?
मेरी मर्जी.
डीएनएस में तो पहनती है.
हाँ ऐसे अच्छी लगती हूँ मैं. चल छोड़. Yesterday I was reading a newspaper.
Which newspaper? The Hindu?
फिर से इंटरप्ट कर रहा है.
कुछ और पढ़ लेना था ना.
हाँ ठीक है, उसी का सब्सक्रिप्शन है मेरे पास.
ठीक है ठीक है.
ठीक है. तो yesterday I was reading an article about NISAR satellite. Okay. So I was fascinated by the fact that how far ISRO has come. We all know that from its humble beginnings in 1960s. Okay. We have seen that image when that satellite was
Satellite
being
parts were carried on the bicycle.
carried on the bicycle, right? So from there, now we see that ISRO is one of the major players in the space sector, right? So what do you think about this journey of ISRO? And in the recent times, what were the movements, any movement, which captured your imagination in the recent time regarding the developments by ISRO?
Well, capturing the imagination, I would have said 2011 World Cup victory.
It's been time now.
But then
India needs to win another World Cup.
Yeah, but then the subject is space organization. So I'll start off with August 23rd last year. India Chandrayaan 3 landed on the moon.
Okay.
That was the movement which captured not just mine and yours, but probably the entire nation's imagination.
We all were glued to a mobile screen.
Exactly. So that episode of moon landing itself, it was indicative of many ups and downs the ISRO has been through since the time it came into fruition, and that was many moons ago.
Yeah.
Sorry, unintended.
No pun intended.
Yeah. So many of you must have traced the beginnings of ISRO like back to 1960s when INCOSPAR was formed,
Yes.
but it was not then. It was even before that.
From when? Since when?
In 1945, Dr. Sarabhai established Physical Research Laboratory in Ahmedabad. And on the same year, Dr. Homi Bhabha, who many of us don't know about his contributions in the space journey because he was India's
Father of nuclear science.
Nuclear science, exactly. So he started Tata Institute of Fundamental Research in Mumbai.
Okay.
And both these two individuals, they did experiments regarding cosmic radiation,
Yes,
upper atmosphere, and the changes that happened. So that formed the what you can call a foundational genesis of India's space science.
Space program and satellite development also
And
in future.
it paid rich dividends in 1962 when INCOSPAR was formed by Pandit Nehru on advice of Dr. Sarabhai.
Okay.
And formation of INCOSPAR in 1962 and subsequently in 1969, ISRO was formed.
Conceptualized and developed.
They did many experiments, which was very, in current scenario, if you think of those experiments, they were very primitive in a way that the experiments conducted,
They were formative in nature.
yeah, they used sounding rockets.
Sounding rockets.
Sounding rockets, they are just basic form of rudimentary form of rockets that are used to take measurements. They carry simple instruments, measurements of temperature, pressure differences,
In the
wind
Earth
speed in the atmosphere of the Earth.
Correct.
Now, basically, for all these functions, we use weather balloons. But these sounding rockets, they go
To
higher altitudes as compared to weather balloons. So that enables any space agency, for that matter, to gain knowledge about the changes in pressure, temperature, etc.
Correct.
So this was the genesis that these sounding rockets were used to gain knowledge about the space events. And this formed the first step of the ISRO proceeded to developing satellites. So what do you think about the satellites that ISRO developed after sounding rockets?
Yes. See, as far as I remember, in the year 1975, India launched its first rocket, though it was launched from Russia, right? So it was Aryabhat in 1975, right? Now, why were Aryabhat launched? Because it had to measure some measurements, like it had to do some measurements in the upper atmosphere of Earth to gather some data, right?
Okay.
Which formed the basis for later on satellite development and launch from Earth, right? And then in 1980s, we had another series of satellite, Rohini and Bhaskar. Okay, so
which came before, Bhaskar or Rohini?
Actually, Bhaskar and Rohini both were related to remote sensing.
Okay.
And Rohini series came earlier, but the first satellite of Rohini series, it was a failure, right? And then we launched Bhaskar, and the first satellite of Bhaskar was India's first remote sensing satellite, which was launched. Okay. And then after it, what we saw later in 1980s, we saw INSAT. You know INSAT?
INSAT are the communication satellites,
Communication
right?
satellite. They are multi-purpose satellite used for communication as well as meteorological purposes also. Okay. And then later, in later 90s, like to be more precise, in 1998, we developed GSAT series of satellites. And basically they were more advanced form of INSAT. Okay, so they focused on advanced communications, right? GSAT series. So this was what we did in terms of.
बैठे क्यों नहीं है खड़े?
अरे यार, this was all what India did.
मतलब plan करके आई थी है ना?
हाँ, ठीक है. In its satellite journey, okay. So later in 2016 we can see Navik series also. That is a different thing. But now we all know that when we developed such satellite.
But don't you think development of all these satellites meant that?
Coming.
Yeah. You were saying something.
बोल.
The development of all these satellites, don't you think they required more and more instruments? Then by that virtue, those satellites will be much more heavier than the initial satellites.
Yes.
So how do you think ISRO graduated from sending a very lightweight satellite to then saying heavyweight satellites into space?
ISRO has a series of rocket launch vehicles. We all know PSLV, GSLV. So tell me something about PSLV. What do you know about PSLV?
Now, see, what I understand is development of larger and more powerful satellites.
Okay.
They require the development of larger and more powerful satellites. They obviously get heavier.
Okay.
So you need to send those heavier payloads into space, and for that you need launch vehicles.
Obviously.
I left at saying sounding rockets, and these were very rudimentary form of rockets. And then through iterative approach, first ISRO mastered its technology over sounding rockets. Then they started developing more and more advanced launch vehicles.
Okay, so PSLV in this journey was the third generation of satellite launch vehicle.
Yeah.
And
after that came GSLV.
okay.
PSLV, see, the one transformative step that was taken was development of PSLV. Because since then, we have seen PSLV has been highly successful in sending payloads. Yeah, exactly. And few years back, I remember the one single mission of PSLV, it sent more than 100.
It was in 2017 when one launch of PSLV C-37, okay? It launched 104 satellites in one go. Yeah,
so that 37 रट के आई थी ना?
नहीं मुझे पता है यार. Commercial 37. So it was a big feat. Now we all know about it, right? And then there comes GSLV Mark II.
Yeah, GSLV Mark II, from what I understand, was also powered by Vikas engine. There's this interesting fact that India wanted an engine for its launch vehicle purposes, be it PSLV and GSLV. Right. So that time in 75 exactly, ISRO approached the French Space Agency for the technology which was related to their Viking engines. But on the other hand, French agency, they were of the opinion that you have to give us something in return of that.
Yeah.
So they demanded ISRO to send engineers to French space agencies, and they were supposed to be working as at almost 100 years of manpower work they were required to put in exchange of transfer of technology.
I was not aware of this.
Okay. So this transfer of technology enabled, first of all, as those scientists went to France, they were able to experience the kind of technology and expertise that the French have. And then when they came back to India, in addition to transfer of technologies, it helped them develop Vikas engine. And the Vikas engine, when it developed in India, upon testing, it was found out that it was even better than Viking engine. For the fact that it went on and it functioned for larger duration, and it gave more thrust. That means it had much more power.
That's why we can see Vikas engine in the second stage of
PSLV. So even
second stage of GSLV.
GSLV also we use Vikas engine.
Yeah, in launch vehicle Mark III also.
Exactly. But then there was this very big difference between PSLV and GSLV. Yeah. That enabled GSLV to send heavier payloads into the space. Yeah. So from what I understand, the GSLV, it was able to send those loads into space because it had cryogenic engine.
Cryogenic technology.
So what do you think is a cryogenic engine and how it is different from, say, why don't we use Vikas engine for that matter?
Okay. See, we also use Vikas engine in the second stage of GSLV Mark II and in the second stage of GSLV Mark III, which is now known as launch vehicle Mark III, right?
Okay.
But see, there was a departure in the cryogenic engine. Why did we use it? Because cryogenic engine. First of all, these are the engines which use cryogenic fuels. So they use liquefied hydrogen as a fuel and liquefied oxygen as an oxidizer, right? And now see, what is different in cryogenic fuel is that they have high specific impulse. This means that for the same amount of propellant which is exhausted in a cryogenic engine, it gives more thrust as compared to liquid engines or other solid engines.
So I think it enables the cryogenic engine to deliver more power with less amount of fuel.
Yes, exactly.
So again, this will help any space agency to put more payloads into the satellite because automatically
this will make more room in the launch vehicle for carrying more payloads or more satellites. Okay, so this is the first advantage. Okay, but and secondly, the cryogenic fuel, it has better fuel efficiency also. This is also thing. And thirdly, so because of all these reasons, using cryogenic engine will be more cost effective, right? So these were some of the reasons.
But why didn't India was able to say get transfer of technology for manufacturing of these cryogenic engines? Because we had other partners also.
Okay, so there was a story that early in 1980s, India was procuring this cryogenic technology from Russia. Okay. But then under the MTCR regime, US threatened Russia to put on some sanctions on the country if it transferred the technology to India, because India was not a party to MTCR. Okay, Missile Technology Control Regime.
So that
Okay.
in that
sense,
that prevented Russia from transferring the technology of cryogenic engines to India.
Okay, initially in 1990s. So what did we do? We procured 7 cryogenic engines from Russia, and then we learned from those engines, right? And then we were able to make our own indigenous cryogenic engine, and that happened when we developed our indigenous cryogenic engine, that is cryogenic engine CE20.
Okay.
We were able to develop
This
that in
powers
India.
GSLV Mark II or the LVM3?
It powers launch vehicle Mark III.
Okay.
Our indigenous cryogenic engine powers launch vehicle Mark III. Okay. So
Okay.
this was how we were able to develop a more this sophisticated technology. And even I can tell you
So in a way,
fun fact.
this ban on ISRO proved to be a blessing in disguise.
Lesson for India.
Exactly.
Why? Because this GSLV Mark II, it has been termed as naughty boy. You know why?
Why?
Because
जबरदस्ती बोलेगी तो पूछना ही पड़ेगा ना.
No. It's a fun fact, right? So in this GSLV Mark II, out of 16 launches, there have been 4 failures.
Okay.
This is a significant failure rate
25%
for any
of failure.
for any launch vehicle, right? And now, if we compare this to LVM Mark III, out of its 7 launches, there have been no failure. Okay, so
Okay.
this is what an indigenous technology. It made us self-reliant also, and then it was more powerful also and more advanced, right? And then with this, और क्या पूछना है तेरे को? Ask something.
तो मुझसे भी तो पूछ कुछ.
अच्छा कि what do you think कि how far ISRO has made advancement in its space missions? What do you think of India's space missions?
See, development on satellites on one hand and development of launch vehicles on another.
And
It in a way enabled ISRO to have send its satellites, other probes into outer atmosphere.
Okay.
First, they used PSLV to send Mangalyaan and Chandrayaan-1, which we saw Chandrayaan-1 had rich dividends in a way that it found water on
Yeah,
moon.
presence of water was certified. On
And
Moon
then, also with Mangalyaan, we saw India became the first country that was able to send a probe to another planet in its first attempt. So that was a transformative step as far as PSLV was concerned. With GSLV, we saw we were able to send Chandrayaan-2 to moon, and again Chandrayaan-3 to moon. But again, the failure of Chandrayaan-2 as it collided rather than making a soft landing on moon, this saw that even in these periods, ISRO met with many failures. And just by,
But
in
we
a
can,
similar way,
but
as
we can
aspirants...
use the orbiter of Chandrayaan-2, right?
Exactly. But in a similar way as aspirants, they take up mock test and they see their failures, they are able to then scale up their performances in
Every failure has a learning.
Exactly.
If you work upon it.
So ISRO did exactly what every aspirant do.
Okay. So then, in future also, we have certain missions of ISRO's which are lined up. We will come into
One
it.
I remember is Gaganyaan, which was sending humans to space, low Earth orbit.
Low Earth orbit, and that is to be, hopefully, it will be done in next
Coming
year.
years,
No, in 2025, next year only. Okay.
So this is one, and I remember Aditya L1 was launched
Aditya L1
recently.
launched recently last year. It was a first India's solar-based observatory.
Enabled ISRO to gauge solar mass
It was
injections,
to study sun basically and its atmosphere.
coronal mass injections and all. And after that, I think ISRO in recent times have also tried to build this capacity of private sector to take up some of its functions. So why do you think is that?
You know, earlier, before 2020, we know that space sector, there was ISRO's complete monopoly on the space sector, right?
It was a monopoly, or the private sector was not able to scale up there?
No. Basically, it may be both the cases, but what I think that personally, ISRO had entire monopoly on the space sector, right? But after 2020, there was slew of reforms. Okay, so what I can recall is India's national space
memory
policy.
तो बहुत अच्छी है, what I can recall.
India's space policy India has a dedicated space policy which was launched last year in 2023, and which put forward the vision of ISRO, and which is to which is for greater involvement of private sector in India's space sector. In India's space operations and space sector, right? And then this has two advantages. First of all, participation of private sector would boost innovation in the space sector, okay? Development of rocket subcomponents or various other space vehicles and related things, okay? And then other thing is that it will free ISRO to do its routine task.
Not routine task, exactly opposite. It will...
No, it will free from doing its routine task,
okay.
and ISRO can dedicate more time
on its strategic objectives, like
in
sending humans to space.
More on research and development, okay? And more in future space missions, okay? This is what...
And there are also, from what I understand, extraplanetary or interplanetary missions that ISRO has planned in...
Before it, I want to say some more thing. That recently in February 2024 only, government has bought 100% FDI in space sector, right? So there is up to 100% FDI in space sector, for which this will also enable greater participation of private sector, okay? And then ISRO has also created certain bodies. Government of India has created
1x pe bol Pooja, 1x pe.
Government of India has also created certain bodies like NSIL, New Space India Limited in space, and these are for better facilitation of this process, okay? Stream integration of private sector into the functions of
So
ISRO.
the routine task of ISRO will be taken up by private sector, and then ISRO will be focused into and then make greater stands into extraplanetary missions and sending humans to space.
Yeah.
Correct. So, but let me ask you one last question. That is probably the elephant in the room. That India is a lower middle income country according to World Bank.
Okay.
It has many shortcomings, say in healthcare, education sector. The infrastructure level is something we need to develop more. So do you think, is it justified to spend so much money, as in ISRO currently has a budget of 13,000 crores, more than 13,000 crores?
I would...
So if spending that kind of money, aren't we better off if we spend that money on, say, other sectors?
No. I would like to disagree with you, okay? You know, if you compare the
ये मैंने
budget...
पूछा नहीं था, मुझे बोला गया था पूछने के लिए.
if you compare the budget which ISRO has, right? The budget of ISRO is quite low as compared to other space agencies, like for example that of China, that of US, okay? So, and the scale of space sector in India, presently as per an estimate in 2023, it was around $8 billion in India, the presence of India's space segment, okay? But then, the global space market,
What was $8 billion?
$8 billion is the size of India's space economy or market presently, okay? But if you compare that with the global numbers, it is around $450 billion. And if you compare these two numbers, India has less than 2% presence or less than 2% share in the global space economy, right? So this requires to scale up India's presence in the global space market, right? So we need more funds, okay? So where is this funding going to come from? This will come from private sector also, of course, because we have liberalized.
तेरा कैसेट तो private sector पे अटक गया.
Private sector पे नहीं, as you say कि why? Because government also need to fund more ISRO, so we need to expand our space operations.
But what about social?
Okay, I'm telling you that this is why we need more funds. Okay, first question. Second thing is like, this space-based operation, they have multiple socio-economic benefits for the country. Ask me how.
मुझे पता है आपको. Ask me how.
First thing is remote sensing satellites. Okay, development of remote sensing satellite as well as navigation system. What are its uses? Okay, tell me. You tell me.
Remote sensing
will. बहुत पता है, बता दे.
Remote sensing will enable us to gauge the exact productivity of our agriculture sector.
Resource mapping, agriculture resource.
Exactly. Will enable ISRO to even gauge the presence of critical minerals and other important
water, presence of water,
metallic and
soil
non-metallic
health. Okay,
minerals.
these are all the things. Resource mapping is one thing. Okay. Second thing is disaster monitoring. You can see the movement of glacier. You can see the movement of tectonic plates. Okay, by
And
some
not just the
advanced-
movement, but development of satellites, say for communication, will also enable us to contact each other with the help of satellite.
Yeah, I was
Exactly.
coming there, but earlier I was saying that it can map resources, obviously, okay? And so by disaster monitoring, it will enable us to give early warning, us to develop early warning systems like forest
Okay.
fires and other systems, right? Second thing is communication, as you already told, okay? So with the use of satellite, we can do satellite-based internet. And satellite-based internet, though it is not mainstream, but satellite-based internet can be used in remote locations.
Matlab you can watch your reels even in higher Himalayan.
Okay, yeah.
areas, right?
Yeah, and plus it is used by defense forces.
Okay.
Because of many things, privacy concerns, and these all things, it is more safe and reliable.
But also to highlight that ISRO has also given its technology to private sector. These are known as spin-off technologies.
Yeah.
For example, usage after using space-based materials, the ISRO, it has developed bionic limbs which are used by people who have disabilities, and then also it was able to manufacture ventricular pumps which help people having heart disease.
Correct.
In addition to that, there was this silica aerogel, which is now used by people in defense forces to gain a different layer of padding on their high altitude gears.
Battery components also, even the
Yeah,
battery
recently,
components.
ISRO democratized its lithium-ion technology to private sector, which then will enable private sector to manufacture lithium-ion batteries, and these were used by ISROs in their satellites.
Okay, one more thing. Apart from all these things you are telling, ISRO is not just using the resources, rather ISRO can also generate revenue. How? Because say if any foreign country is asking ISRO to launch its satellites, okay, so we are going to earn that revenue. The second thing is space tourism, which will be a thing in future, right? So ISRO, by utilizing all these services plus the aid of private sector, we will be able to do more innovations in that field, and we will be able to generate more revenue by space tourism. Okay, so these are some of the things.
तो स्पेस टूरिज्म तो तब आएगा ना जब खुद पहले
क्या?
एस्ट्रोनॉट्स जाएंगे स्पेस में.
हाँ ठीक है ना, तो वही मैंने बोला ना, फ्यूचर में होगा ये सब,
Future
पर
में.
होगा लेकिन नियर फ्यूचर ओनली. डोंट बी दैट पैसिमिस्ट अंकित.
हो गया?
हाँ हो गया तेरा.
चाय पीने चले
हो गया
कि
बस.
वहाँ पे भी यही चलेगा?
हाँ चल ठीक है.
ठीक है.
पैसे कौन देगा चाय के?
मैं दे दूंगा.
तू देगा पैसे. ठीक है, तब चलते हुए. तो इतना इंटरप्ट करता है ना, तू बोलने नहीं देता, या फिर तू ऐसे बोलेगा, तू
तो
बोलने नहीं.
अच्छा ना, अब जब मेरे पास एलिगेशन लग ही रहा है तो अगली बार मैं और नहीं बोलने दूंगा. इफ देयर इज अ नेक्स्ट टाइम.
ओके.